Hey everyone! Welcome back to my channel. Today, we're diving into a really interesting Codeforces problem called Make It Beautiful. This problem is all about binary numbers, flipping bits, and using power in a clever way. So let's break it down step by step and solve it together. Here's the idea. You are given an array of numbers, and you are allowed to increase the value of any number by flipping some of its binary bits from 0 to 1. But, there's a catch. Each bit flip costs some power. You're given a limit, let's call it k, and you can't spend more than that. Your goal is to use this power wisely to maximize the total number of ones across all numbers in the array. Sounds fun? Let's see an example. Let's say the array is 1, 2, and 3. And we're given k equals 5. We'll go step by step and see how we can make the array more beautiful. First, we convert these numbers to binary. 1 represent in binary as 1 0 0 0, which has 1 1. 2 represent in binary as 0 1 0 0, which has 1 1. 3 represent in binary as 1 1 0 0, which has 2 1s. So total number of ones at the start is 1 plus 1 plus 2 equals 4 ones. Next, we want to flip some zeros into ones. But remember, flipping each bit costs power depending on the position. Bit 0, rightmost, costs 1. Bit 1 costs 2. Bit 2 costs 4. Bit 3 costs 8. And so on. Let's use our k equals 5 power in the best way possible. Let's start with bit 0 cost is 1. We look at each number. 1 already has 1 at bit 0, we skip. 2 has 0 at bit 0, we can flip it. Cost equals 1. New binary of 2 equals 0 0 1 1. 3 already has 1, we skip. Now we've used 1 power. Remaining equals 4. And we've added 1 new one. Next, bit 1 cost equals 2. 1 has 0 at bit 1, we flip it. Cost equals 2. New binary of 1 equals 1 1 0 0. 2 already flipped, we skip. 3 already has 1, we skip. Now we've used 2 more power, total used equals 3. Remaining equals 2. And we added another 1. Now, bit 2 cost equals 4. But we only have 2 power left. We can't afford it, so we stop here. Let's look at the final count of ones. Original total, 4. Plus 2 new ones we flipped. Final answer, 6 ones. That's the most we can get under the limit of 5 power. And that's how we solve this problem bit by bit, flipping only what we can afford. Okay, let's talk about the code. Here's how the code works. Loop through each bit position from 0 to 62. For each bit, loop through the entire array. If that bit is 1 in the current number, count it. If not, check if we can afford to set it using k. If yes, increase the answer, and subtract the cost from k. At the end, we print the total number of ones. It's a greedy and bitwise solution, and it works even with huge values of k. This solution runs, since there are 63-bit positions in a 64-bit integer. It avoids brute force and handles big inputs like a champ. And that's it. Bit manipulation problems can be tricky, but once you get the idea, they're really satisfying. If you found this helpful, don't forget to like the video, subscribe for more problem walkthroughs, and leave a comment with your favorite bit tricks. Thanks for watching, and see you in the next one.